Hi, welcome to this video where we will show you how to multiply two polynomials by each other. Before I actually show you the process, I want to explain a few things that you already know, mainly because understanding these ideas may help you understand why the process is the way that it is. If you remember right from the distributive property, when you have a quantity out in front of a set of parentheses, you can distribute it to each of the terms within the parentheses. So in other words, in this case, you get AB plus AC. Multiplying something that's more complicated is really just a double application of the same thing. If I take all of C plus D and treat it as though it were the A, treat it as though it were the A because it is the quantity that is outside this set of parentheses, I can now take the whole C plus D and distribute it to both of those terms. So what I get is a parentheses C plus D times the E, and then added to C plus D times the F. Then notice that this right here looks an awful lot like it's in this kind of setup. So I have an E bumping up against the parentheses. I can distribute the E to both terms. So EC plus ED. And then to that I'm going to add the distribution of the F to both terms because that also looks like that. So CF plus C DF. So that would be DF. So notice what we end up with right here. We end up with four terms, and notice that basically in the original problem the C got multiplied by the E, and it also got multiplied by the F. And the D got multiplied by the E, and the D also got multiplied by the F. So essentially, if we were to summarize what's happening here, the procedure for multiplying two polynomials together is you take the first polynomial and every single term in the first polynomial gets its turn multiplying every single term in the second polynomial. As you can see in problem number 1, we have a two-term polynomial multiplied by a three-term polynomial. So if we were to apply this procedure to this, we would multiply the 5x by the x squared, so we get 5x cubed. We'd multiply the 5x by the second term, or the 2x, and we get 10x squared. And then we multiply the 5x by the 3 and get a 15x. Now we have exhausted all the terms with the 5x, and it's now time to take the 4 and multiply it by each one of the terms. So the 4 times the x squared gives us 4x squared. The 4 times the 2x gives us an 8x. And finally the 4 times the 3 gives us a positive 12. At this stage we've actually completed the entire multiplication, and all that's left for us to do is to simplify the result. So we're going to collect like terms. Notice that this is the only x cubed term right here, so that has nothing to combine with. We just have 5x cubed. As far as x squared terms go, we have a positive 10x squared and we have a positive 4x squared. So that gives us positive 14x squared. Then we have an x term here, and we have an x term there, so a positive 15x plus 8 more x would give us 23x. And then finally, this number term, there's only one of those, so we just tag that along without combining it with anything. So our final answer right here is this. The actual multiplication, though, is what caused us to get these 1, 2, 3, 4, 5, 6 terms that we got before we had ever combined. A nice thing to realize is this was 2 terms times 3 terms, which was different than the illustration we had on the previous part of the video. Notice the procedure did not change. It was still every term in the first quantity gets its turn with every term in the second quantity. Let's look at one more example. Notice with this problem, it's not an example that has 2 terms times 3 terms, but rather 3 terms times 3 terms. The nice thing to know is that that does not change the procedure at all. So we're going to distribute every term in the first quantity to every term in the second quantity. If you can see, that will produce 3, 6, 9 different terms, and then we'll have to combine the like terms among those 9 terms. So to make it a little easier for myself later on when it comes time to combine like terms, I'm going to illustrate here how I might as well stack up the like terms right to begin with. So what I'm going to do is I'm going to multiply this by each one of these. And I get myself x to the 4th plus 2x to the 3rd minus 10x squared. Now it's the 7's turn. So multiplying the 7 by each one of these terms, I get a 7x times x squared would be 7x to the 3rd. I might as well line that up underneath the other cubic term. And then the 7x gets multiplied by the 2x, so that's a 14x squared. I'm going to line that up underneath the other x squared term. And then finally the 7x times the negative 10, which gives me a negative 70x. Notice that's not lined up with any term, but that's because we haven't encountered any other x terms up to this point. Now the 3 gets its chance to multiply each one of the terms in the second quantity. So the 3 times the x squared gives me 3x squared. I might as well line that up underneath the x squared terms. The 3 gets to multiply the 2x, so that's a positive 6x. And then finally the 3 gets multiplied by the negative 10, which produces a negative 30. Basically, if there's no terms in a row, that just means there's only one term that's to the 4th power, so I just carry that down. Then plus 9x cubed. And then here we have a 14 and a negative 10, which is a positive 4x squared. And then a positive 4x squared plus 3 more would give us positive 7x squared. And now we have a loss of 70 and a gain of 6, so that's going to be a negative 64x. And then the minus 30 doesn't have anything to combine with. So there we multiplied 2 polynomials together, and this would be our final answer, written in the most simple way that it can be. Here are 4 problems for you to try on your own. Make sure to leave enough space between each problem so that your work is not cramped. Please bring your work to class next time. Hope this video was helpful.